It changed color again, but this time something is very, very different. The interstellar visitor 3IATLAS just turned bluer than the sun itself, and NASA has now confirmed something that, according to conventional physics, shouldn't be happening. We're watching this object accelerate in ways that gravity alone cannot explain. Is this the most bizarre comet ever observed? Or are we witnessing something that will rewrite our understanding of what's possible in the universe? What you're about to hear in the next 10 minutes will challenge everything you thought you knew about comets. Stay with me, because the evidence we're going to present is extraordinary. And by the end of this video, you'll understand why scientists around the world are losing sleep over this object. Good morning. This is a special documentary report on 3IATLAS, the interstellar comet that refuses to behave like any comet we've ever seen. My name is on the screen, and over the next 10 minutes, I'm going to walk you through the latest developments that have the scientific community both fascinated and deeply puzzled. Before we dive in, if you appreciate this kind of in-depth science coverage, please hit that like button and subscribe to our channel. It genuinely helps us bring you more content like this. We're tracking this story in real time, and your support means we can keep doing this work. Now, let's get into what's happening. October 29, 2025, the date when 3IATLAS reached perihelion, its closest point to the sun, at a distance of 126 million miles. On that day, something extraordinary happened, and we only found out about it because of spacecraft positioned around the sun that could still see the comet while it was hidden from Earth. Those spacecraft, Stereo, SOHO, GOES-19, and Punch, captured images that revealed something nobody expected. The comet had undergone a dramatic transformation. It was no longer the reddish object we'd been tracking since July. It wasn't the greenish object we'd observed in September. Now, it had turned distinctly blue. Not just blue, bluer than the sun. Let me explain why this matters. When astronomers look at comets, they expect to see reddish colors. Why? Because comets are covered in dust. When sunlight reflects off dust particles, it gets reddened, just like how sunsets appear red. The dust scatters away the blue light and leaves us with the warmer, redder wavelengths. But 3IATLAS is doing the opposite. It's emitting more blue light than the sun itself. The sun's surface temperature is about 5,800 degrees Celsius. For an object to appear bluer than that, it would need to be even hotter, or it would need to be emitting light through some other mechanism entirely. Harvard astrophysicist Avi Loeb put it bluntly in his analysis. The appearance of 3IATLAS as bluer than the sun is very surprising. Dust is expected to redden the scattered sunlight, and the surface of the object is expected to be an order of magnitude colder than the sun, resulting in it having a redder color. We must therefore add the blue color at perihelion as a ninth anomaly to the list of unexpected properties of this strange interstellar object, a ninth anomaly. Let that sink in. We're not talking about one or two unusual features. We're talking about 9 distinct characteristics that make this object unlike anything we've cataloged before. And Loeb asks the question that nobody wants to ask out loud. Does it employ a power source that is hotter than the sun? Now, before you think this is just one scientist being provocative, let me give you the context. Multiple spacecraft observed this blue coloration independently. The LOSCO instrument on SOHO, the CCO or 1 coronagraph on GOES-19, the SECI instruments on Stereo. All of them recorded the same thing. This isn't a measurement error. This isn't a camera artifact. This is real dot, and there's more. At the same time these observations were being made, NASA's Jet Propulsion Laboratory released an official report. The author, Davide Farnokia, a navigation engineer who specializes in calculating the trajectories of objects in our solar system. His report confirms something that adds a whole new layer to this mystery. 3IATLAS is exhibiting non-gravitational acceleration. That's a technical term meaning the object is moving in ways that cannot be explained by gravity alone. The measurements show a radial acceleration away from the sun of 135 kilometers per day squared. and a tangential component in the direction of its motion of 14 kilometers per day². Now, for natural comets, this isn't entirely unusual. Comets can exhibit non-gravitational acceleration through something called outgassing. As the sun heats a comet, ice turns directly into gas without becoming liquid first. This gas jets away from the comet's surface, creating thrust, like a natural rocket engine. But here's the problem. The amount of acceleration being observed suggests that 3IATLAS would need to be losing mass at an extraordinary rate. According to the calculations, if this acceleration is being caused by outgassing, the comet should lose approximately half its mass over the next 6 months. In the month it takes to cross the perihelion region alone, it should lose about 10% of its total mass. That kind of mass loss would create an enormous debris cloud, a massive plume of gas and dust that would be impossible to miss. We're talking about over 5 billion tons of material being ejected into space. The gas cloud should extend hundreds of thousands of kilometers around the nucleus. Telescopes on Earth and in space should be able to see this debris field easily when the comet emerges from behind the sun. But here's what's keeping scientists up at night. We haven't seen the debris cloud yet. The comet is expected to become visible again to ground-based telescopes on November 11th. When it does, observers will be looking for that massive gas plume. If it's there, case closed. Natural comet behaving unusually, but still natural. If it's not there, then we have a serious problem, because that would mean 3IATLAS is accelerating through some other mechanism. And Loeb doesn't mince words about what that other mechanism could be. Alternatively, the non-gravitational acceleration might be the technological signature of an internal engine. An internal engine on an interstellar object. Let me be absolutely clear. Most scientists do not believe this is the case. But the fact that we're even having this conversation in peer-reviewed papers and official NASA, our EPORTS tells you how unusual this situation has become. If you're finding this fascinating, and I hope you are, please take a second to like this video and subscribe. We're going to be following this story through December, when the comet makes its closest approach to Earth, and you'll want to be here for those upgrades. Your engagement really does help us continue this coverage. Now, let's talk about the color changes, because this is the third time 3IATLAS has apparently changed color, and each time tells us something important. In July, when the comet was first discovered and observed by Hubble, it appeared distinctly reddish. This made sense. The comet was far from the sun, covered in dust, reflecting reddish sunlight. Standard comet behavior. Then in September, as it got closer to the sun, observers noticed it had turned greenish. This also made sense. The green color in comets typically comes from the carbon molecules or cyanide compounds in the coma being excited by solar radiation. Still unusual for an interstellar comet, but not unheard of. But now, at perihelion, it's blue, and this doesn't make sense in the conventional framework. Loeb's analysis suggests the possible explanations. 1. The blue light is coming from ionized carbon monoxide gas being superheated near the sun. This would be an extreme version of natural outgassing, but it's possible. 2. The blue light is coming from an artificial source, a hot engine, artificial lighting, or technology. Live Science reported just hours ago that this blue coloration may not be permanent, just like the previous color changes. They noted that early observations showed red, then temporarily green, and now blue, but none of these colors have persisted. The question is, why would a comet's color change so dramatically and so frequently? What's happening on or inside this object that's causing these shifts? The scientific paper analyzing the rapid brightening near perihelion states that LOSCO color photometry shows the comet to be distinctly bluer than the sun, consistent with gas emission contributing a substantial fraction of the visible brightness near perihelion. So, the blue color is likely related to gas emission. But what gas emits blue light that's bluer than the sun? And in what quantities would it need to be emitted? Here's another piece of the puzzle. The CCO, or one instrument on GOES -19, resolved a glow extending out to 300,000 kilometers around 3IATLAS. that's comparable to the scale of the carbon dioxide plume detected by the Spheric Space Observatory back in August. So, there is a large gas envelope around this object. But is it large enough to explain the non-gravitational acceleration without creating a visible debris field? That's the question. And then there's the Kardashian factor. Yes, you heard that right. On November 2nd, Kim Kardashian, who has over 360 million followers on social media, asked NASA Acting Administrator Sean Duffy a direct question on Twitter: is 3IATLAS dangerous? Duffy's response was immediate and clear. NASA's observations show that this is the third interstellar comet to pass through our solar system. No aliens, no threat to life here on Earth. Now, you might wonder why we're mentioning the celebrity's tweet in a science documentary. Here's why. Kim Kardashian's question reached more people in 24 hours than every scientific paper on 3IATLAS combined. When one of the most followed people on Earth asked about an interstellar comet, millions of people who would never read an astronomy journal suddenly become aware of this object, and NASA had to respond publicly on the record to address concerns. The fact that NASA felt compelled to explicitly state no aliens tells you something about how this story is being perceived by the public. Whether scientists like it or not, 3IATLAS has become more than just an astronomical curiosity. It's become a cultural phenomenon, and that brings us to Avi Loeb's controversial scoring system. Loeb has created what he calls the Loeb Scale, a framework for evaluating whether an object might have a technological origin. It's scored from 0 to 10, where 0 means definitely natural and 10 means definitely artificial, based on the 9 anomalies now associated with 3IATLAS. Loeb gives it a score of 4 out of 10. 4 out of 10. That's right in the middle. Not natural, not artificial, but genuinely ambiguous. Let me list those 9 anomalies for you. Its trajectory is aligned within 5 degrees of the ecliptic plane where all the planets orbit. Random chance, 0.2%. It displayed a sunward jet in July and August, which is extremely rare for comets. Its nucleus is 1,000,000 times more massive than Oumuamua and 1,000 times more massive than Borisov, making it by far the largest interstellar object we've discovered. Its arrival timing brought it close to Mars, Venus, and Jupiter while remaining hidden from Earth at perihelion. Combined probability, 0.005%. The gas plume contains much more nickel than iron, similar to industrial nickel alloys, and the nickel to cyanide ratio is orders of magnitude higher than any known comet. It exhibited non-gravitational acceleration at perihelion, confirmed by NASA. It passed perihelion just 8 days after solar conjunction relative to Earth. Optimal timing for any maneuver to be unobserved. Observations by multiple spacecraft show rapid brightening near perihelion that exceeded normal cometary behavior. The object appeared distinctly bluer than the Sun during perihelion passage, suggesting either extreme outgassing or another heat source. 4 out of 10 on the technological origin scale. Now, most astronomers would argue that 4 out of 10 still means probably natural. But Loeb's point is that we can't dismiss the possibility out of hand. We need to keep observing, keep measuring, keep gathering data, and that's exactly what's happening. The International Asteroid Warning Network IAWN has announced a special observation campaign targeting 3IATLAS from November 27th through January 27th, 2026. This is unprecedented. IAWN typically focuses on potentially hazardous asteroids that might impact Earth, but they've now designated 3IATLAS as a training target for improving comet astrometry. Some have interpreted this as a sign that IAWN considers 3IATLAS potentially dangerous, but the reality is more nuanced. Comets present unique challenges for accurate trajectory predictions. Because their outgassing can change their paths unpredictably, ION is using 3IATLAS as a test case to improve our ability to track any comet accurately. Not because they think the specific comet is a threat. So, what happens next? Let's lay out the timeline. November 11, 2025, 3IATLAS 3IATLAS becomes visible again in the pre-dawn sky for ground-based observers. Amateur astronomers with 8-inch or larger telescopes should be able to see it. At around magnitude 10 to 11, the critical question: is there a massive debris cloud? Has the comet visibly lost mass? Early November, ESA's JUICE spacecraft, currently on its way to Jupiter, will observe 3I/ATLAS from about 0.4 astronomical units away. However, because JUICE is using its antenna as a sunshield, the data won't reach Earth until February 2026. December 2025, the James Webb Space Telescope will make its second round of observations. After perihelion, these will provide detailed spectroscopic data on the comet's composition and activity levels. December 19, 2025, closest approach to Earth at 168 million miles. This is our best chance to study the comet in detail. Hundreds of professional and amateur telescopes will be pointed at 3IATLAS. The Hubble Space Telescope will conduct ultraviolet spectroscopy to determine the composition of gas emissions and the sulfur-to-oxygen ratio. March 16, 2026, close approach to Jupiter at 33 million miles. NASA's Juno spacecraft will have an opportunity to observe and potentially detect radio transmissions, if any exist. Between now and December, we'll either see clear evidence of massive outgassing explaining the non-gravitational acceleration, or we won't. If we do, the mystery is solved: unusual comet, but natural. If we don't, the scientific community will have to seriously grapple with alternative explanations. Professor Darryl Seligman from Michigan State University, who has been studying 3I/ATLAS since its discovery, remains confident in the natural explanation. He stated, "There have been numerous telescopic observations demonstrating that it's displaying classical signatures of cometary activity," and he's right. The James Webb and SPHERICS observations clearly detected carbon dioxide, water vapor, carbon monoxide, and other molecules consistent with comet outgassing. But the counterargument is equally valid. Yes, it looked like a comet, but comets don't typically exhibit non-simultaneous anomalies. At what point does unusual natural object become possibly not natural? That's the philosophical and scientific question at the heart of this debate. Here's what I find most compelling about this whole situation. Both sides have good points. The skeptics are right to demand extraordinary evidence before accepting extraordinary claims. The mere fact that something is unusual doesn't make it artificial. Nature is capable of producing wildly improbable coincidences. But the advocates for continued investigation are also right. We've only discovered 3 interstellar objects ever. Our knowledge of what's normal for interstellar visitors is based on an absurdly small sample size. Maybe interstellar comets are just weird. Maybe the conditions that allow an object to travel between stars for billions of years create characteristics we don't yet understand. The beauty of science is that we don't have to choose sides prematurely. We can simply say, here's what we know, here's what we don't know, here's what we're going to measure next, and then follow the evidence wherever it leads. And that's exactly what's happening. No conspiracy, no cover-up, just systematic scientific investigation of an object that refuses to fit neatly into our existing categories. If you've stuck with me this far, thank you. This is complex material, and the fact that you're here watching a 10-minute documentary on comet physics means you're genuinely curious about the universe. That's exactly the kind of audience we're trying to reach. So please, if you haven't already, hit that subscribe button. We'll be covering the November 11th observations, the December flyby, and everything in between. You won't want to miss it. Let me leave you with this thought. Whether 3IATLAS turns out to be the strangest comet ever observed or something else entirely, we're living through a remarkable moment in astronomy. For the first time in history, we have the technology to study interstellar visitors in real time with multiple space telescopes, Mars orbiters, Jupiter probes, and global networks of ground-based observers all coordinating their efforts. Carl Sagan once said, "Somewhere, something incredible is waiting to be known right now." That something is 3IATLAS, 3IATLAS, and in the next few weeks, we're going to know a lot more about it. The universe has sent us a messenger from another star system. It's traveled for possibly 7 billion years to reach us, and it's doing things we don't fully understand yet. That alone should fill us with wonder, regardless of whether it's natural or artificial, whether it's ice and rock or something else. This is what exploration looks like. This is what science looks like when confronted with something genuinely new. Not proclamations of certainty, but careful observation, rigorous measurement, and the humility to admit when we don't yet have all the answers. Keep watching the sky, keep asking questions, and keep demanding that we follow the evidence wherever it leads. If you want to stay updated on this story as it develops, subscribe to our channel and turn on notifications. We'll be here every step of the way, bringing you the latest observations and analysis. Until next time, stay curious. This report is based on current information as of November 5th.